To all. In my last video, we discussed about arithmetic properties of complex numbers such as addition of complex numbers, subtraction, multiplication, as well as division. And also we discussed one of the concept, what is mean by conjugate of a complex number. Now, in this session, we are going to discuss some problems which are related to those concepts. Now, I will start today's session with some of the problems. We'll begin our session with our first question is, express each one of the following in the standard form of a plus iota b. We'll start the first one. 5 plus 4 iota upon 4 plus 5 iota. Let's see. If you wish to express in the form of a plus iota b, we can able to understand very clearly we have to delete the complex number from the denominator. That means we have to convert this complex number into a real number. To convert the denominator into a real number, we have to multiply both numerator and denominator by the conjugate of denominator. We know that what is meant by conjugate of a complex number. From a complex number, if we change the sign of its imaginary part, it will be a conjugate of that complex number. So, I wish to multiply here both the numerator and denominator 4 minus 5 iota upon 4 minus 5 iota. Why 4 minus 5 iota is the conjugate of 4 plus 5 iota. Now, 5 times of 4 is 20. 5 times of negative 5 iota is negative 25 iota. Plus into plus, plus 4 4s are 16 iota. Plus into minus, minus 4 5s are 20, but iota into iota, iota square. Iota square is negative 1. Negative of negative, positive. So 20 upon, it is observed here, 4 plus 5 iota times 4 minus 5 iota. It means it is in the form of a plus b into a minus b. A square, 4 square, minus b square, 5 iota whole square. Now, we have to simplify. 20 plus 20, 40, minus 25 plus 16, minus 9 iota upon 4 square is 16, 5 square is 25, but iota square is negative 1. So, negative of negative, positive 25. Now, we will get 40 minus 9 iota upon 41. Can we write it as 40 minus 40 upon 41 minus 9 upon 41 iota? Observe now, here our a value is 40 upon 41 and b value is 9 by 41. I hope it's clear. Now we will begin the next one. What is the next one given? The second problem they given as 1 plus iota whole square upon 3 minus iota. Observe here, numerator is in the form of a plus b iota whole square. That means a plus b whole square. So we have to simplify the numerator first, then we will multiply both numerator and denominator by the conjugate of denominator. Now a plus b whole square, a square, plus b square, iota square, plus 2ab, 2 into 1, 2, 2 into iota, 2 iota upon 3 minus iota. Now observe, 1 square is 1, iota square is negative 1, plus 2 iota upon 3 minus iota. Can I cancel positive and negative 1? Now what we got finally? 2 iota upon 3 minus iota. Now we will multiply by 3 plus iota upon 3 plus iota. Since 3 plus iota is the conjugate of 3 minus iota. Now what we will get? 2 3s are 6 iota. 2 iota into iota minus 2 upon 3 minus iota into 3 plus iota These are also in the form of a minus b into a plus b. So a square is nothing but 3 square minus b square is nothing but iota square. What we will get now? We get, can I write it as minus 2 plus 6 iota upon 3 square means it is 9. Iota square is nothing but negative 1, negative of negative, positive. So it become minus 2 plus 6 iota upon 10. Can I write it as negative 2 by 10 is nothing but negative 1 upon 5. 6 upon 10 is nothing but 3 upon 5 iota. I hope these two problems are clear. Now we will discuss the next problem. If z equals to 4 plus iota times square root 7, then find the value of z cube minus 4z square minus 9z plus 91. Let's see. Observe here. Z equals to 4 plus iota times square root 7. Can I write it as z minus 4 equals to iota times of root 7? Why? Positive 4, when we are transposing from right hand side of equal to the left hand side, it becomes negative. Now I want to squaring on both sides. So squaring on both sides. What do we get now? Z minus 4 whole square equals to iota into root 7 whole square, right? Now z minus 4 whole square means z square, a square plus b square 16 minus 2ab 8z equals to I square is negative 1, square root 7 square means 7, so negative 7. Can I write it as z square minus 8z? Now minus 7 transposing from right to left, it becomes positive. 16 plus 7 plus 23 equals to 0. I am considering this as equation 1. Now I wish to divide z cube minus 4z square minus 9z plus 91 by using equation 1. Let's see what it will get. Now, let's see now. Z square minus 8z plus 23 is going to divide z cube minus 4z square minus 9z plus 91. Now, z cube here z square. So, we have to multiply by z. Z into z square, z cube. Z into minus 8, minus 8z square. Z into plus 23, plus 23z. Now, subtract. While subtracting, you have to change sign. Positive become negative, negative become positive, positive become negative. Positive z cube and negative z cube get cancelled. Negative 4, positive 8. So positive 4 z square minus 9 minus 23 minus 32z plus 91 as it is. Now here z square is there, but here 4z square is there. So we have to multiply by 4. So 4 into z square, 4z square. 4 into minus 8z minus 32z. 4 23s are 92. Now subtract. While subtracting, these two get cancelled, these two get cancelled, you will get negative 1 as your remainder. We know that division rule. What is long division rule? Dividend equals to divisor into quotient plus remainder. So by using that, can I write it as z cube minus 4z square minus 9z plus 91 equals to, that means dividend equals to divisor, z square minus 8z plus 23 into quotient. Quotient is z plus 4 plus remainder. Remainder is minus 1. But from equation 1, z cube minus 8z plus 23 value, what you got? 0. So can I write it as 0 into z plus 4 minus 1 is nothing but 0 and anything is 0 minus 1. That equals to minus 1 is your final answer. I hope it's clear. Now, our next problem. Yes, a plus b minus iota times of 3a plus 2b equals to 5 plus 2 iota. Let's start. Observe here. A plus b minus iota times of 3a plus 2b equals to 5 plus 2 iota. Observe, left hand side complex number real part is a plus b, right hand side complex number real part is 5. And left hand side complex number imaginary part is 3a plus 2b, right hand side imaginary part is 2. But these two complex numbers are said to be equal. When two complex numbers are said to be equal, if and only if their imaginary part as well as their real part should be equal. So by using that property, can I say that implies a plus b equals to 5 and 3a plus 2b equals to negative 2. Why negative 2 here? Because here minus, here plus. Now, by using these two, we have to find out a value as well as b value. We have two equations and we want to find two unknowns. So we can solve easily by using the concept of, we know, elimination method, substitution method. We learned that linear equations in two variables. By using that, so I wish to multiply my first equation by 2. When I am multiplying my first equation by 2, I will get 2 times of a, 2a plus 2 times of b, 2b equals to 2 times of 5, 10. Now here 3a plus 2b equals to negative 2. Now subtract. It become minus, it become minus, it become plus. These two get cancelled. 2 minus 3 minus a equals to 10 plus 2, 12. So a value is negative 12. Once we got the a value, just replace this a value in any one of the equation to extract or find the value of b. But we know that a plus b equals to what from the equation 1, 5. Substitute a value here, minus 12 plus b equals to 5. So b equals to 5, minus 12 becomes plus 12. So b value is what? 17. I hope it's clear. Now we are going to discuss next problem. Now the next problem is, if square root of x plus iota y equals to plus or minus a plus iota b, then find the value of square root of negative x minus negative iota y. Let's see. Solution will be square root of x plus iota y equals to plus or minus a plus iota b is given. Now I want to squaring on both sides to remove the square root. So what I will get, x plus iota y equals to a plus iota b whole square. Now that implies x plus iota y equals to a plus b, iota a square plus b square. That means iota b whole square plus 2 iota ab. Now observe that implies x plus iota y equals to a square. Iota square is nothing but negative 1. So negative b square plus 2 iota ab. Now compare both the complex numbers of real parts as well as imaginary parts on both sides. So you will get x equals to a square minus b square and y equals to 2ab. Check. Now, but we have to find out the value of square root of negative x minus negative iota y. Replace the value. Square root of negative of, what is x value? A square minus b square minus 2 iota ab. Y value is 2ab. Can I write it as square root of, here negative of negative, positive b square. So I am writing the positive value first, b square minus a square minus 2 iota AB. Observe here, that implies that equals to square root of B square plus A square can be written as iota A whole square. Why? It is negative A square. Because iota square is negative 1, negative of positive, negative A square only. Minus 2 iota AB. Why we are written like that? Now observe, it is in the form of A minus B whole square. So we can write it as square root of B minus iota A whole square. Now square and root get cancelled. You will get plus or minus B minus iota A. What is left side is running? That is nothing but square root of negative x minus negative iota y. So negative x minus negative iota y value you got plus or minus B minus iota A. I hope it's clear. Now see the next problem. Given that x comma y belongs to real numbers, solve x upon 1 plus 2 iota, x upon 1 plus 2 iota plus y upon 3 plus 2 iota equals to 5 plus 6 iota upon 8 iota minus 1. Let's see here. Observe very carefully. X into 1 minus 2 iota upon 1 plus 2 iota into 1 minus 2 iota. That means just I rationalize the first fraction, the conjugate of its denominator, plus similarly the second one, y upon 3 plus 2 iota, just you have to multiply by 3 minus 2 iota upon 3 minus 2 iota equals to, what is your right side value? 5 plus 6 iota upon 8i minus 1. So you have to multiply by 8i plus 1 upon 8i plus 1. Now what it will become? Now observe, that implies x times of 1x minus 2x iota upon 1 square 1. Here a plus b into a minus b only. A square minus b square. 2 square is 4. Iota square is negative 1. So plus 4. That is positive 1 into positive 4. Positive 4 plus y into 3. 3y minus 3. 2 into iota. So 2 iota y upon, here 3 square 9. 2 square 4, but iota square is negative. Negative of negative, positive 4 equals to, observe here, 5 times of 8, 40 iota. 5 times of 1, 5. Now 6 8s are 48. Iota into iota, iota square negative 1. So that is negative 48. 6 iota into 1 plus 6 iota upon 8 iota whole square. That means 8 square is 64. Iota square is negative 1. So negative 64 minus 1. Now observe here, what you got? X minus 2x iota upon 5 plus 3y minus 2 iota y upon 9 plus 4 13 equals to 40 iota plus 6 iota, 46 iota plus 5 minus 48 minus 43 upon negative 65. While doing LCM, left side part, 5 and 13 LCM is 65. So 13 times of x minus 2x iota plus 5 times of 3y minus 2 iota y equals to, can I write it as 43 minus 46 iota upon 65? Why I multiplied numerator and denominator by negative sign of the right side fraction. Now these two fractions are equal, so we can cancel 65 and 65. Now what we will get? Let's see here. 13x minus 13 twos are 26 x iota plus 5 threes are 15y minus 15 twos are 5 threes are 15y. Now 5 twos are 10. 10y, 10 iota y equals to what? 43 minus 46 iota. Observe here, that implies real part 13x plus 15y. So 13x plus 15y, I am putting in one bracket, minus 26 x iota minus 10 I iota. So I want to take iota common. So 26x now plus 10y equals to 43 minus 46 iota. Now compare both sides. That means 13x plus 15y equals to 43 and 26x plus 10y equals to 46. Now we have to solve to find x and y. Here see 13x, here 26x. So we can understand very clearly. We have to multiply first equation by 2. So if you multiply that, 2 13s are 26x plus 2 15s are 30y equals to 2 43s are 86. Now 26x plus 10y equals to 46. Now subtract. This to get cancelled, it is 20y. 30 minus 10 equals to 86 minus 46 will be 40. So your y value is 2. Now replace your y value in any one of the equations. Suppose I replace y value here. 15 twos are 30. 43 minus 30 will be 13. So x value will be 1. I hope it's clear. So you will get x as 1 and y as 2. We will discuss our next problem. If x plus iota y whole cube equals to u plus iota v, then show that u upon x plus v upon y equals to 4 times of x square minus y square. We will try this. Let's see here. Better I will change the color. Given x plus iota y whole cube equals to u plus iota v. Okay. We know that a plus b whole cube. That a plus b whole cube, I will write here better to understand very clearly. A cube plus b cube plus 3a squared b plus 3ab square. Now, I am applying that identity. A cube, x cube plus b cube. That means iota cube, y cube. Iota cube is what? Iota square is negative 1. Again into iota means negative iota. So negative iota y cube. Plus 3a square b. A square is x square. B is iota y. So plus 3x square y iota or 3 iota x square y. You can write like that also. Next here plus 3a b square. But b is iota square y square. Iota square is negative. So negative or positive? Negative. Here 3x y square is nothing but right side u plus iota v. Now observe here. X cube minus 3xy square. I am writing the real part as at one place. Minus, if I will take iota common, that means suppose better I will take plus iota common, then 3x square y minus y cube. I hope it's clear because I am taking I common from this term 3x square y. Next I was taken this term, that is minus y cube, is nothing but u plus iota v. Now here your u value is x cube minus 3x square y, and v value is 3x square y minus y cube. Now, what do you want to find actually? U upon x. U upon x plus v upon y. Now, from this, u value x cube minus 3x square y. Can I take common x? If I take common x, we will get x square minus 3xy upon x plus, from this equation, can I take y common? 3x square minus y square upon, if you are taking common y, no, 3x square minus y square upon y. What you will get now here? Y get cancelled, x get cancelled. What we will get here? Observe very clearly here, if you take common x square common here, x common 3xy. I wrote correctly, I hope so. U value is x cube minus 3xy square. Sorry, there is a mistake here. We have to write 3xy square here. 3xy square. So when we are taking common x, we will get here y square. Y square. Now what we got finally? U upon x plus v upon y equals to x square minus 3y square plus 3x square minus y square. Now what you will get? X square plus 3x square is 4x square minus 3y square minus y square is 4y square. Can't we take common 4? So 4 times of x square minus y square. What is left side is running? U upon x plus v upon y. Hence proved. I hope it's clear. Yes. Discuss about properties of conjugate of complex numbers. I wish to share my screen here. Now. Now let's see here. I am writing properties of conjugate of complex numbers. Complex numbers. Clear? Now, we'll discuss one by one. First one. Suppose z equals to a plus iota b. Then you know that what is z bar? A minus iota b. We wish to find out z plus z bar. Z is a plus iota b plus z bar is a minus iota b. Can I cancel iota b, positive and negative iota b? What you got? 2a. A is what? Real part. So 2 times of real part is nothing but real part. So can I say that z plus z bar, you are getting only 2a. That means the sum of a complex number to its conjugate is always a real part. Sum of complex and its conjugate will always give you a real part. Now, we will discuss z minus z bar. Similarly, a plus iota b minus of a minus iota b. That means a plus iota b minus a, negative of negative, positive iota b. Now we will get cancelled. Positive and negative, you will get 2 times of iota b. That means you are getting only an imaginary part. Imaginary number. That means the difference of a complex number to its conjugate will always give an imaginary number. The sum of a complex number to its conjugate will always give a real number. Okay. Now we'll try to find out the product of a complex and its conjugate. So z is, I was taken already, a plus iota b, and z bar is, a minus iota b. What is z? times of z bar, that equals to a plus iota b times a minus iota b. It is in the form of a plus b into a minus b. So a square minus b square, iota b whole square. That is nothing but a square plus b square. Why? You know, iota square is negative 1, negative of negative positive. This is, you got z bar. I hope it's clear. It is also a real number. Clear? Now, we have to find out z bar to the whole bar. That means conjugate of complex number. Let's see, is always equals to a z. I will prove this. Just for example, I am taking z equals to a plus iota b. Then tell me what is its conjugate? A minus iota b. Then what about its conjugate? Z bar whole bar. That means you have to change the sign of imaginary part. So a plus again iota b. But a plus iota b is nothing but your original complex number. Can I write it is nothing but z only? No. So the conjugate of a complex number will always give itself. I hope it's clear. Now z1, for example, a1 plus iota b1 I am taking. z2 equals to a2 plus iota b2. First I want to find out z1 plus z2. What is that? You know that already. In last class we discussed a plus a1 plus a2 plus iota times of b1 plus b2. Am I right? I want to find the conjugate of z1 plus z2. So z1 plus z2 whole bar equals to, can I write a1 plus a2? Just we have to change the sign of imaginary part, right? So minus iota times of b1 plus b2. I am considering it as my equation 1. Now I want to find out what is the conjugate of z1? a1 minus iota b1, right? What is the conjugate of z2? a2 minus iota b2. I want to find now z1 bar plus z2 bar. What is z1 bar? a1 minus iota b1 plus a2 minus iota b2, right? Can I write it as a1 plus a2 minus iota b1 minus iota b2? Just rearrange the terms. Can I write it as a1 plus a2 minus, if I wish to take common iota minus iota, then b1 plus b2, right? I am considering it as equation 2. What my left side is running? z1 bar plus z2 bar. Observe equation 1 and 2. Can I say that from equation 1 and 2, equation 2, we get z1 plus z2 whole bar is always equal to z1 bar plus z2 bar. I hope it's clear. You can say that z1 minus z2 bar is always equals to z1 bar minus z2 bar, and z1 z2 whole bar equals to z1 bar into z2 bar. Please remember these properties. Now we'll disconnect.